Waidsumacademy. Today we're taking chemistry, and our topic for chemistry today is polymers in organic chemistry. Okay, polymers. So first of all, what are polymers? Polymers are large molecules. They are micromolecules that are made from small molecules. So polymers are large molecules that we call micromolecules. They are large molecules that we call micromolecules. So we say polymers are large molecules. Polymers are large microbes. The word poly means many. The word poly means many. So meaning polymer, it means derived from many monomers. Okay, derived from many monomers. The small units are called monomers. Just the way you say amino acid for the smaller unit of protein, the small unit for polymer is called monomers. Now many monomers combine together to form what? Polymer. To form what is called polymer. So poly means many. So when you hear poly, where's monomer? Sorry. Poly means many and mono means just one. Mono means one. So in other words, when we say polymer, we are saying macromolecule, giant molecule, macromolecules. That's what we mean by polymers. Macromolecule, not just molecule, but macromolecules. That's what we mean by polymers. They are large molecules. They are large molecules that are formed from smaller units of other molecules. So it could be like up to 10, 20, 50 monomers, small units coming together to form a giant structure called the polymer. Okay, forming a giant structure called the polymer. Each, we repeat, unit, it's your unit, and will be connected to each other, and they will bond together covalently. So each monomer bond to itself covalently to form a giant macromolecule. So it's just like in the case of ethene, when we're doing addition, when we're taking addition polymerization. So ethene, okay, let me show you properly. So we say carbon to carbon double bond. Okay, we have ethene carbon to carbon double bond, and then we have our hydrogen bonding. See, these are covalent bonding. These are all covalent bonding. So this will add to itself in the other type of polymer called the addition polymerization. This ethene, which is an organic compound from alkenes family, will bond onto itself repeatedly to form a giant macromolecule called the polymer. So if we want to make a polymer out of this, we will multiply it by n number of times, by itself n number of times. So I can just multiply the outside here by n. I'll multiply it by n, meaning it will add onto itself at so many number of times, and then we will get a structure like this, a monomer like this, sorry, a polymer like this, which is going to be a macromolecule, a strong macromolecule, okay, and this will be the polymer. The ethene will continue to add onto itself and to form a giant structure called a polymer. So this, in this we have, see, even this we can see, put this outside. Here we have hydrogen bond, up and down we have hydrogen bonding, hydrogen bond. So carbon bonds with hydrogen covalently, okay, to form continuously to form this macromolecule. So we have the bonding here. Even if I don't write the hydrogen, you already know there's hydrogen bonding with the carbon in all both the upper direction and the downward side. So the hydrogen bonds here to form a giant macromolecule, and this is called a polymer. This one is called a polymer, while this is the monomer ethene, which add onto itself ethene in addition polymerization. This type of polymerization is called addition polymerization. This type of polymerization is called addition polymerization. Ethene will continue to add onto itself to form a giant macromolecule, which is called a polymer. So polymers are obtained from two different broad types. We have the synthetic polymer and we have the natural polymer. The synthetic polymer and the one that are being manufactured probably in the laboratory or in any of this in the industries, these are the synthetic polymers. The synthetic polymer itself is divided into two: additional polymerization and covalent polymerization. Condensation polymerization. So synthetic polymer, the one we manufacture, they are divided into two. There's the additional polymerization method and the condensation polymerization method. While the other branch of polymer, which is called, we said polymer is divided broadly into two. So the term polymer itself is divided into two. If I have polymer here, I will split it into two major types. And these two types are the addition, or two types of making polymer, or two methods of polymerization. One is called the synthetic. Number one is called synthetic polymer or polymerization. And then the second one is the natural polymer. These are the two broad types of polymerization: natural polymer. Okay, these are the two basic types of polymer. We have the synthetic polymer and we have the natural polymer. Now let's take a look at synthetic. We say synthetic is again divided into two. The synthetic is again divided into two. The first one is additional polymerization, and the second one is called condensation polymerization. The synthetic polymerization or polymer is divided into two types: the additional polymerization and the condensation polymerization. Okay, and then we have the condensation polymerization. This is the second one for synthetic polymer. So we're going to look at this briefly, okay, in our next section. Addition and the condensation polymerization, we're going to look at it briefly in the next session. Probably we'll take one more example: the making of nylon, the making of terylene, all of these things, they fall under the additional polymerization. While the making of polythene is other additional polymerization. So we're going to take a look at this, okay, broadly. So we have condensation polymerization, we have additional polymerization. Natural polymers, will be having things like protein. We'll be studying the structure of protein, how Almighty God, the creator of everything, made monomers to join together to form this giant macromolecule. Monomers like amino acid, how they join together to form this giant macromolecule called the protein. And then carbohydrate, how the glucose join together to form starch or carbohydrate. So we go also carbohydrate. So we also going to look at this one. We're also going to look at this one as a natural polymer. Carbohydrate as a natural polymer. The third one is fat or lipid. We're also going to look at that. Okay, other natural polymerization. We're going to look at the fats and the lipids, other natural polymerization. Okay, so now let's move on. So here we say polymers are giant macromolecule. We've already said linking small monomers together to form a giant macromolecule, and they do this by bonding covalently with each other. Some polymers, they just contain one type of unit only, like those ones are called additional polymerization, like in the case of ethene or chloroethene, which is PVC. The PVC pipe is made from additional polymerization. How? This is when ethene begins to add onto itself, or chloroethene, yes, more specifically chloroethene, begin to add onto itself to form what we call PVC, what we call polychloroethene. PVC is polychloroethene. All these are additional polymerization, or polyethene itself, ethene added onto itself. Okay, these ones are made up of same monomers. The monomer is just same, but it's added onto itself. One type of monomer only. So when you have one type of monomer only added onto itself, is called additional polymerization, or the synthetic or additional polymerization. So in additional polymerization, we're going to talk about it more extensively, but let's just give a brief introduction to it. In addition polymerization, we only have one monomer that is being added onto itself. Okay, one monomer, same monomer, or you can write one monomer, same monomer. Okay, that is added onto itself. A good example is ethene, same monomer that is added onto itself to form a giant micromolecular structure. Okay, so it could be a good example of the monomer. We put the monomer in bracket. A good example of the monomer is ethene. Okay, but not only ethene, even chloroethene. Chloroethene can continuously and constantly add onto itself to form this. Another one is chloroethene. Chloroethene can continuously and constantly add onto itself to form this polymer. Okay, so these are a good example of monomers that are used in addition polymerization. There are more, but these are the few examples. But when we talk about condensation polymerization, we have two or more types of monomers. This one is made up of two or more types of monomers. Two or more monomers. Two or more monomers, other condensation polymerization. Let's change our color. Two or more monomers. When you talk about condensation, when you're talking about condensation polymerization, this is made up of two or more monomers. Okay, this is made up of two or more monomers. Okay, but when we're talking about addition polymerization, it's just one monomer that is added onto itself, continuously added onto itself to form a giant micromolecular structure. Is that okay? Okay. Now, other type of monomers, such as condensation, that are made in the condensation process, they contain two or more different types of monomer units, and which are called copolymers. Okay, they cohabit, they coexist, because it's not only one monomer. A good example is nylon or terylene. A good example is nylon. For this one, good example is nylon. Nylon. Is that N here? No. Then another one, terylene, right? Terylene is another example. Okay. Terylene is another example. They are made up of two or more monomers that cohabit. So they are called copolymer. This type of polymer, they are copolymer. Because the monomers are different. Copolymers. The monomers are different. So they join together, but they are not same. So they are called copolymers. Okay, the polymers that are formed from this type of monomers, they are called copolymers. Is that okay? Now, different linkages exist depending on the monomers that were used to form the polymer. Different linkage will exist depending on the monomers, the different monomers that you use in forming the polymer. Okay, so example of linkages are the covalent bonds that are formed. One is at the amine leakage and the ester leakage. Okay, the amine leakage, especially when we do the condensation polymerization. The leakage that will be formed in condensation polymerization, one of it, leakage formed in condensation polymerization. Leakages are one, amine group can be formed when we do condensation polymerization. Okay, we have leakages formed. Number one is amine group. The amine group, the NH2, the amine group, okay, the amine group that is formed, and another group that can be formed is what? Which other group can we form? Another group that can be formed is the ester leakage, right? The ester leakage, okay, the ester leakage. I think we will see this when we will see this when we study condensation polymerization. Okay, so this is what it is. This is what we get. Okay, now this monomer, same unit. Okay, these are single units. These are single units. If you look at them, they look same color, same shape. All of this, what we mean by addition polymerization, is each unit, each one is a monomer, and this one we join together due to heat and pressure, join together to form a chain, to form a long chain called a polymer. Okay, these single ones are, so the process of joining single unit of monomers, single unit called monomers of same type to form a same type or different type to form a giant micromolecule, the process is called polymerization. It is the process we call polymerization. The process of making polymer is called polymerization. The process of making polymer is called polymerization. Okay, so now for addition polymerization, we already mentioned that you can take ethene to add onto itself multiple number of times, under pressure and heat, and then it will form a polyethene. Ethene we add onto itself to form polyethene. Why we put bracket N here is that we're saying this continuous. Okay, I've showed that already from the beginning of the class. From the beginning of the class, I have demonstrated that already. We said ethene, you take ethene like this, and it will add onto itself to form a giant one. In this case, we just show it like more in a continuous form, but in the one on the slides, we only show the abbreviated form. Okay, so you can see this is the polyethene that's formed. Okay, you can also make polychloroethene, which is PVC. Polychloroethene. If you want to make polychloroethene, you have to use chloroethene as your monomer, meaning you replace one hydrogen atom here with chlorine. If you replace one hydrogen atom with chlorine, you also form polychloroethene, which is PVC. So if I take that, I will make a polychloroethene. But in this case, if I just want to show a single unit, and I don't want to show everything, I can just draw my ethene. I can just draw the ethene. Okay, I can draw the ethene like this. I put my N here, like it's being multiplied by N. You can put the hydrogen if you so wish. You can put the hydrogen. You can see the hydrogen bonding with the carbon. This is an ethene, and then this one we polymerize other maybe different heat, presence of heat and pressure and other things. Then this will become let's just draw the single unit, this will become polyethene. This will become a polyethene with a single unit. Let's just show you with a single unit, which means the ethene will continue, which means this one will continue to bond it onto itself. It will become a long chain, but we're just using a single case to showcase it, to show it. Okay, it means it will continue, but this is just a single way of representing it. So you see the double bond will break and it will form single bond, and it will be repeatedly forming a giant polymer. Now if I use chloroethene, if we use chloroethene, for example, we put here one hydrogen here. Instead of hydrogen, we put chlorine here. Okay, this becomes chloroethene. So I have a hydrogen atom here, bonding with carbon, hydrogen atom here bonding with carbon. But here, instead of having hydrogen, I decide to have chlorine. Now if I have this, if I make it under pressure and heat to add onto itself, we have a polychloroethene. How? Meaning this one will become carbon to carbon single bond, no more double bond. It will continue. I just want to show the simplest case. It will continue. It's going to continue. Other heat, pressure, whatever that is applicable. Okay, other heat and pressure. Then we will get polychloroethene. Here we have chlorine. Here we have chlorine atom. Okay, every second one at the bottom one you put chlorine atom. You see, the 6 chlorine is on the second one. So if I want to continue, if I want it to continue, what I will do is that the next one, if I have 1, you know, I already have like 1, carbon 1, this carbon 1, this carbon 2, this carbon 3. Okay, if I have my carbon 4, meaning I've counted another one. So here I have hydrogen. I have hydrogen. Okay, I have hydrogen. Let me take different color. I have hydrogen. Here I have hydrogen. Okay, here I have hydrogen. Okay, this is my, you know, after 1, 2, this is like 1, 2 again, or 3, 4. Here I will have my chlorine, because we are getting polychloroethene. Remember that we are getting polychloroethene. So if I continue, then this is how it adds auto itself. I will count another 2, carbon 1 again, carbon 2, you know, which is actually carbon 5 and 6 in this regard, which is actually carbon 5 and 6 in this regard. So you have hydrogen here. Okay, you have hydrogen here, bonding with hydrogen here, bonding here with hydrogen, and the bottom we have chlorine. We have chlorine again. So this is polychloroethene. If you want to name this, you say this will continue. So we just name it. We can continue to go on like that and in this manner, in this format. So the name will be poly, because you are forming a polymer. The name will be polychloro, because there is chlorine atom every second one. Polychloroethene, because this is ethene that is added to itself. Polychloroethene, and this is what we call polyvinyl chloride. Another name for polychloroethene is called polyvinyl chloride. Polyvinyl, say something like this. Polyvinyl chloride. Okay, and this polyvinyl chloride is what we call the PVC. Polyvinyl chloride is the PVC pipe. Is what you call the PVC pipe for conduit and for plumbing work. For plumbing work the plumbing pipes in our homes is made from. It's actually a polychloroethene. It's a polymer made from chloroethene. It's a polymer made from chloroethene. So polyvinyl chloride. Okay, so all these are addition polymerization. All these are addition polymerization. What we've just looked at is addition polymerization. Anyway, we will see it more extensively. Let's just move on. Okay, so what you see here, ethene added to itself. That's why we put N here, meaning it's going to be added to itself. And this double bond will be broken because due to heat and pressure and everything, we will get more of ethene being added to itself, which is called polyethene. Okay, this is an example of addition polymerization. This is an example of addition polymerization. Okay, now let's take a look at the addition polymerization properly. What we did just now was just...
In this video, we're going to look at addition polymers. Polymers are large molecules formed from joining smaller molecules.
Okay, so let's move on. Polymers are large molecules that are formed from joining small molecules called the monomers. Okay, from joining small molecules called the monomers. Polymers are large molecules. What is polymer? Polymers are large molecules made from linking small molecules together to form a giant macromolecular structure. A giant macromolecular structure. Is that okay? Now let's take a look at addition polymerization properly. In addition polymerization are formed by joining up of many monomers together. Okay, and only occur in monomers that contains carbon to carbon double bond. Addition polymerization only happens where you have carbon to carbon double bond. If you look at the example we've given, there is double bond, carbon to carbon double bond for addition polymerization. Even this, carbon to carbon double bond. So anywhere we're talking about same monomer, but it has carbon to carbon double bond, so that it can be added, can be broken and be added onto itself to form a giant macromolecular structure. One of the bonds in each carbon to carbon bond breaks and form a bond with adjacent monomers on the polymer B formed and contain a single bond only. So we've explained all these characteristics. We say we use alkanes, and usually the alkanes ethene. We use ethene, which is from the alkene family, to carry out this type of polymerization. Okay. If you use propane, it's not only ethene you can use. If you use propane, you get polypropene. If you use propene, you get polypropene. Okay, the polymer will be polypropene. If you use ethene, you get polyethene. Okay, if you use butene, you get polybutene. Is that okay? So that's what it is. That's what it is. Okay. Now, for addition polymerization, it's just the monomer added onto itself, like we have explained. Okay, carbon to carbon double bond. This bond, with other heat and pressure, will break and add onto itself and form a giant macromolecule. Okay. Similarly, if you take chloroethene, it will form a giant macromolecule called polychloroethene, which is PVC, polyvinyl chloride. Okay, so that's for addition polymerization. Now, you say deducing the monomer from the polymers. Now we want to deduce the monomer from the polymer. Okay, repeating units of the polychloroethene. Now you can see, you see C, every CH, the bottom here you have one C, one chlorine, Cl, one chlorine atom. Then you count another 2. The bottom here you have one Cl, the chlorine element or chlorine atom. Then you count another 2, 1, 2. You see chlorine, 1, 2, you see chlorine. So if you want the monomer, because they can give you a polymer and ask you to deduce the polymer. So if you want the polymer from this addition polymerization, if you want the monomer, what you need to do is just to take the first 2 or the last 2. You bring it up and you use double bond. You use double bond to show it. To get the monomer, you use double bond. That's it. Okay? You use double bond to show it. So these are the monomers. These are the different monomers that add onto themselves to form this macromolecule called the ethene. Now let's go to condensation polymerization. Let's go to condensation polymerization. So,
in this video, we will be looking at condensation polymers. Condensation polymers are made from monomers that contain different functional groups. The simplest ones use 2 different monomers that have the
condensation polymerizations are made from monomers that have different functional group. They are made from monomers that have different functional group. Condensation polymerizations, they are made from monomers that contain different functional group to one another. They're different. So in this regard, we'll be using the functional group. Okay, we can use other things to represent. The other molecules. We can use the block to represent other molecules. But the functional group we use the functional group when we are deriving the polymer. We use the functional group when we are deriving the polymer. The simpler one contains 2 different types of monomer, each with 2 of the same functional group. Okay, the simplest one contains 2 monomers. The simplest one contains two monomers. Is that okay? And it can have more than 2 monomers. We can have 3 monomers, 4 monomers, forming a condensation polymer. Forming a polymer through a process known as condensation polymer.
same functional group, such as a dicarboxylic acid and a diol, and a dicarboxylic acid and a diamine. When the monomers react together, they form the polymer. And
so a good example is when we take dicarboxylic acid and dione. Dicarboxylic acid and dione. So when we react dicarboxylic acid and dione, we form a different macromolecule. We will form a different macromolecule. Okay, we're going to look at this in a while, in a short while.
And a second product, which is always a small molecule, typically water. Examples include dicarboxylic acids and diols forming a polyester and water, or dicarboxylic acids and diamines forming a polyamide and water. A condensation polymer can therefore be defined as the...
Okay, here, let's take an example of condensation polymerization. For example, dicarboxylic acid, right? Dicarboxylic acid. So we take this and then we show the structure with dione. Dione is you just have OH functional group from both sides. For example, if we have just a minute, okay? Okay, Now condensation polymerization. For condensation polymerization, two different monomers with two different functional groups. Okay, two different monomers with two different functional groups. We say one is dicarboxylic acid. You could be more specific by saying 1,4-dicarboxylic acid. Okay, dicarboxylic acid plus dione. Okay, this one will form polyester and water. Polyester. This will form polyester and water. We're going to show it. Okay, this one will form polyester plus water. And then another example we can have for condensation polymerization is dicarboxylic acid and amine. Dicarboxylic acid plus amine. Dicarboxylic acid plus diamine, two of it, diamine react together with plus diamine. This one will form polyamine. This will form polyamine. This will form polyamine and water. This will form polyamine and water. This will form polyamine and water. Polyamine. Polyamide plus water. Okay, so for condensation polymerization, these are first two examples. Number one is dicarboxylic acid react with dione to form polyester and water. The second one is dicarboxylic acid react with diamine to form polyamide and water. Okay, more extensively, we're going to look at the chemistry of this. Okay, so we can have a ring, a carbon number 1, 2, 3, 4 for dicarboxylic acid. Okay, we can have like something like benzoic acid or something like that. Okay, but we can just have a straight one and we don't have to spend so much time. So we can simply write, if we have let's use different color. If we have C6H4 C6H4 and then to C the functional group now. What makes it a dicarboxylic acid? Double bond to O, the functional group, the carboxylic acid functional group. Then a single bond to OH on this side, plus the same thing on this side to C, double bond to O, single bond to OH, single bond to OH. Okay, this is dicarboxylic acid react with dione. Now dione is like this. OH on both sides. So dione is C2. If you like, you can write C to C. here we have OH on this side, and you also have OH on this side. OH here. So this, you have hydrogen atom, hydrogen atom, hydrogen atom, hydrogen atom. 2 carbo atom and 4 hydrogen atom. 2 carbo atom and 4 hydrogen atoms. Okay. So if you have this, you will form, remember here's all these molecules, we can use block to represent them. This one we can use block, so which means we can actually write this one like this. We can actually write this one like this using a block to represent all these other molecules. We only consider the functional group when we are writing this equation. We only consider the functional group. So I can rewrite this dicarboxylic acid like this. Okay, we can rewrite this dicarboxylic acid like this. Double bond to O, single bond to OH. Okay. And then similarly here on this side, double bond to O, single bond to OH on this side. Okay. OH or HO is same thing. Okay. Okay. So this we can begin to like shade this one, for example. For this is the structure of the dicarboxylic acid, and then we can also do same here. We say plus this molecule. What we have here, we represent this with a block. Let's change. We represent this with a block. We represent this with a block. Okay, this one maybe we just put dot. Okay, for this dicarboxylic acid, and sorry, for this dione. On this side we have OH functional group. On this side we have the OH functional group. And then on this side, we also have the OH functional group. So instead of writing the other molecules, we only use the functional group and a block to represent. So this entire molecule has been replaced with this block. This entire molecule has been replaced with this block. This entire molecule has simply been replaced. This entire molecule has simply been replaced by only this block only. Okay, we use the functional group, the OH functional group, the dione. The oin. Oin on both sides means dione. Oin on both sides means dione. OH is oin. So on both sides it becomes dione. So we use this OH functional group together with the block. And then similarly, all this other molecule we replace this molecule with a block. We replace it. We don't need it when we're doing this. We just replace all this molecule with a block. And when this happens, this produce what? We produce polyester. A polyester and water molecule. A polyester and water molecule. Okay, we're going to continue this. Let's just pause here and move on. Okay, we make a polyester and water molecule. In the other case, we're making polyamine and water molecule. Polyamine and water molecule. The one with amine is simply like this. Dicarboxylic acid, we write the structure of the dicarboxylic acid for the second one. This for the first one. For the second one, we draw the block diagram, or we write the equation C2H4 to C, double bond to O, then single bond to OH. This is double bond, okay? This is not Z. This is double bond. Double bond to O, single bond to OH on both sides. On the right side and on the left side. Okay, this is a dicarboxylic acid. Okay, so we have double bond here to O, single bond to OH on this side. Okay, this react with amine group. Okay, with an amine group. Okay, and then we will have amine. You have NH. You have NH. Okay. NH2. That's what defines the amine group. So you can have your carbon group, which is your C2H4, and then you have your amine group, NH2. Here you have your N. Here you have your N. one single bond to H here, another single bond to H at the bottom here. Similarly on the right, one single bond to H and one single bond to H this way. So this is what makes it an amine group. This one is what makes it an amine group. This one, this is the functional group, amine. This is the functional group. Okay, all these other molecules we represent with this one makes this one the dicarboxylic acid. This one makes it a dicarboxylic acid. This one makes it the acid. Okay, this and this one makes it an acid. This other molecule C2H4 we represent with a block diagram like this. We just represent this one with this block diagram. So we use this functional group and this functional group together with this functional group and this functional group here. We also represent with a block. We use this function and this function to produce a polyamine. So finishing it up, we're going to continue, but let's move on for this to the next one. Okay. So condensation polymerization. The condensation polymers are formed when two different monomers are linked together. You can see we're talking about dicarboxylic acid. It's a different monomer. Dicarboxylic acid, this is a different monomer, and diamine is a different monomer. So two different monomers coming together to form a polymer, which we're going to draw. We're going to draw the polymer. Okay. Similarly, like this one, the first one, dicarboxylic acid comes together with what? Diamine. With dione. This is a dione. OH functional group. Dione. Okay, this one has OH functional group. So dicarboxylic acid reacts with dione. We produce a polymer which is called polyester. We're going to finish it up. We're going to write it. We'll come back to it. But there's something I want to explain first before we write the structure, the polymer that is formed. The second case was a dicarboxylic and diamine. Dicarboxylic acid and diamine, which is this one. Whose structure is this? Diamine. Amine in one place is amine. Second one makes it diamine. So react with dicarboxylic acid, we're going to form polyamine. We're going to form a polyamine polymer. And this process is called condensation polymerization. Remember, addition polymerization does not require different monomers. It only require same monomer, just add it to itself to form the polymer. Is that okay? Now, we say for condensation polymers, they form when two or more different monomers that link together with the removal of a small molecule, like usually water or hydrochloric acid. Sometimes water is formed, is a small molecule that is formed, and that small molecule needs to be taken out. Usually water and sometimes hydrochloric acid, depending on the monomers. Okay. Now, this is a key difference between. There is always a key difference between condensation polymer and addition polymers. We've itemized those differences. We say in addition polymerization, only one monomer continuously and continually add auto itself. Okay. And in condensation polymerization, two or more monomers come together to form a giant macromolecule. That's one difference. Addition polymerization forms the polymer molecule only. Okay. Addition polymerization forms the polymer molecule only. Condensation polymerization forms the polymer molecule and water molecule per linkage. So this is another difference between them. Addition polymerization only forms the polymer only. It does not form any other compound. But in condensation polymerization, they form the polymer and they also form a water linkage. And if they form water, and there's always a linkage also that's formed between them. The monomers have two functional groups present, one on each end for condensation polymerization. One on each end. If you look at it, there's always two functional groups, one on the right, one on the left. The monomers always have two functional groups, one on the right, one on the left. This is only in the condensation polymerization. In case in the exam they ask you to give the differences between addition polymerization and condensation polymerization. The first one is that both of in addition polymerization requires only one monomer of same monomer to add to itself to form a giant macromolecule. In condensation polymerization, two or more monomers add to them comes together, combine, react together to form a giant macromolecule. And then we say another difference is that in condensation polymerization, they do not only form the polymer, they also form a water molecule and some leakage. They form water and some leakage in the polymer. Then why additional polymerization? They don't form any other compound. Compound. They only form the polymer. They only form the polymer. Okay, so these are some of the differences that you find. The monomers, they have two functional groups present, one in each end. We already mentioned that. Another difference is that in condensation polymerization, the monomers, they have two functional groups, each one on each end of the monomer. The functional group at the end of one monomer react with the functional group on the end of the other monomer. So in doing this, they create a long chain polymer. The alternative monomer creates a long chain polymer. Is that okay? And this is done by hydrolyzing water, okay, to the compound. Okay, so this is how condensation polymerization takes place. A good example is the forming of a nylon. A good example is making of a nylon in the laboratory or in the laboratory or in the industry. A good example is the manufacture of nylon. In the case of nylon, a dicarboxylic acid, as you see, this is a dicarboxylic acid, C2H4 to C, double bond to O, and single bond to OH. And then same on both sides. This is the acid functional group, the carboxylic acid functional group. It's called di because it's on both sides. Now it reacts with what? Amine. It reacts with amine group, the one we wrote just now. When this happens, this OH in the acid, we take H in the amine. We take one H in the amine to form water. This will form water, H2O. This will form water. Okay, this process is condensation polymerization. So you can be more specific in naming this. So when what we're going to have is that there will be no OH. There will be no OH at the bottom of this because the OH has been extracted to form water. There will be no OH here. The OH has been extracted to form water. Okay, and there will be no 1H on the amine side. There will be no 1H. Only 1H on top will remain, but the H at the bottom will no longer be there on the amine side, this end side. So because 1H has been taken to form water. And here, there will be no OH here because it has been extracted to form water. So no OH at the bottom of here and no H at the bottom of this amine. So it's to form water. These two atoms, the OH and the H, has been extracted to form this water. So this is the product that is formed. This is the product that is formed. But to be more, and this is called an amide linkage. Amide linkage. This NH is called an amine linkage. This whole thing, NH and C to double O. This whole link is called the amine linkage. Okay, this is going to continuously repeat itself to form a structure like this. Remember I said we will remove these other molecules, we replace them with block. We remove all these other molecules, we replace them with blocks. Okay, so in the case of this one, we also remove it and replace it with block. So because the OH at the bottom here has been taken out, the OH at the bottom here also taken out. When it continuously reacts, the H here has been taken out. In this case, we just take the one from the top. Okay, the H here has been taken out. This is what we're going to find. This is the overall product that is formed. This product is what we call the nylon. This product is what we call the nylon. In this case, we will be having double bond to O on both sides, and we have only N to H. There is no. So if we come to our equation we wrote before, if we come to this equation, hey, mute your microphone. If we come to this equation, what we have for this amine case, what we have is that this H we take on this OH. So what we have is that this H we take on this OH, this one. To form water. Okay, to form water. So and similarly, even this OH will be taken by the next H that is supposedly be active with it. You know, it's a continuous chain. So we assume this will also take on this. So in the end, what we will have will be a result like this. What we have will be a result like this. You have a C to the bond. We have the bond. And then to C here, we only have double bond to O. Double bond to O. The single bond to OH, the OH has been used up to form water. The OH has been used up to form water. This OH and this H, they form water. They form water. Okay? This H and this H, and also similarly this H also form water. So what we have in the end is double bond to O. Same here, double bond to O. And then to the next one, to C. Okay, to N in this case, if we are reacting with amine. Okay, this one is for amine. But this one is to O. Okay. This one is to O. O to the block, the second block. O to the second block. Well, let's change the color. The second block, we use dots. And then out here to O. And then again to C. C double bond to O. Single bond to the block. Comes out again to C. Comes to O. Comes to the next leakage, which is dione. And comes out to O. So this is what is going to continue. This is what is going to continue. This is what is going to continue as your polymer. This is not for nylon. For nylon, we are using this one, amine and carboxylic acid. But this is for production of another thing which is called polyester, right? Polyester. So this is ester leakage. What you see here is called ester leakage. This one. Let's change the color. This is called the ester leakage. This place. We say ester leakage. Ester leakage. And this polymer is called polyester. Remember, plus water, okay? Water has also been formed, plus water. And this polymer is called polyester. This polymer that is formed is called polyester. This polymer that is formed is called polyester. So, okay, polyester, this is how we make it. We take, a dione reacting with that carboxylic acid. You know, here I said here is 2, okay? Okay, we take that dione, reacting with that carboxylic acid. So we get polyamine and water. Okay? Okay, this polyamide, this is called the ester leakage. This is called the polyester, the ester leakage. Is that okay? Now let's take a look at this one, the second one. The second one is similar way. When the product that is formed, let's go to the product straight away because we've looked at the reactant before. So we've represented this with a block. Remember, this is a block. This is a block. This is a block. So double bond to O. The OH is going to be used up. This OH is going to be reacting with this H to form water, right? Similarly, the one here also with the one on the right, with the H on the right, they will react together to form water. So different molecules of water will be formed. Now, this one to the block, to our block. There on the other side, which is this side now, the second functional group, we write our C. Double bond to O, double bond to O, double bond to O. Then the OH down has been used to form water. The next step, it goes to this nitrogen. It goes to this nitrogen and then single bond to H, this H on top. And then to the block here, the block we're using for this one. You know, we're going to use block for each of the other molecules except the functional group. So the block we are using here, we link it to this. We link the block we are using here to this. We link the block to this, and then it comes out with the same thing, and the single bond to H. Then it goes back to where you started from. It's linked again to where you started from. So we say to C, double bond to O. No more OH. Remember, the OH has been used to form water. And then to the block for the carboxylic acid, what we use to represent the carboxylic acid other molecules except the functional group. And then comes out with the C also again to double bond to O, and then to N, single bond to H, then to your block for the other compound, the other monomer, which is amide, and then comes out again with N, single bond to H. So at the end of the day, this plus water is formed, okay? Plus water. At the end of the day, there's always plus water. Water molecule has been taken out. This water molecule has been removed. Has been removed. Has been removed. How? How? You can see from here. We say this OH will react with this H. This OH will continuously react with this H, and this OH will continuously react with this H to take all the water molecule out. So at the end of the day, this is formed. Okay? This polyamide is formed. Okay? This is an amine linkage. So we call this an amine linkage. We call this amine. We call this amine leakage. Amine leakage. And this is how nylon is made. This is how the making of nylon is. Okay? Making of nylon. Using condensation polymerization. Manufacture of nylon. Nylon. Okay, you use that carboxylic acid to react with polyamide, and then you will produce this structure. You produce this structure that is called the ester. Okay, this polyamide. The polymer is a polyamide. Okay, so this is what condensation polymerization is. So in the exam, they expect you to be able to do this. They expect you to be able to give this whole leakage for what is going on. Is that okay? So I think a little practice will give you a complete insight to what it is, okay, how it is being formed. Now this is for terylene. Terylene is for dione. When you are making dione, react with that carboxylic acid. Terylene is for dione. Okay, so when you're making terylene, you use you make dione to react with the carboxylic acid. It could be cyclobenzene or something like that to react, and then you manufacture terylene, and you will make an ester leakage, double bond to O single bond, like the first one we did. Okay, it's an ester leakage. You create an ester leakage, double bond to O and single bond to O. This is an ester. I already mentioned this. This is an ester leakage. This is manufacture of terylene. This is for the manufacture of terylene. Terylene. Okay. While the second one is the manufacture of nylon. This second one is for the manufacture of nylon. Okay. So this is what you just need to practice, and then you will be good to go. Okay, this is for terylene. There's an ester leakage that is formed, double bond to O, single bond to O, double bond to O, single bond, like the first one we did, and then the second one was for nylon. So with this, we've come to the end of our today's section. We've reviewed overview condensation and addition polymerization, and we've also reviewed polymer, what it is, and then the next one will be probably maybe a synthetic polymerization. The next one will be synthetic polymerization. So with this, we've come to the end of our section for today. Is that okay?